Hi everyone, welcome to another video. My name is Makon. So in this video we will be discussing about regression. So basically three types of regression is what I am thinking of doing today. So it will be simple linear regression, multiple linear regression, as well as quadratic regression. So we can start it. So actually here I have some variables. So x1 x2 x3 q1 q2, so I'm just taking x1 x2 x3 for linear regression. So here let x1 be my dependent variable and these two be my independent variable. So at first let look at simple linear regression. So x1 and x2, so this is my dependent variable, this is my independent variable. So you can go by analyze, and here you have regression. So there is linear regression. So in linear regression you have to give your dependent variable. So here x will be your dependent variable and your independent variable is x2. And in statistics you can give confidence interval 95% and descriptives if you need. So you can click on OK. So usually we will give options. In options you will have everything is okay, so there's nothing to change in that. This is plot, so if you are interested you can give this plot also. So it will be like z predictive on the x-axis and z residuals on the y-axis. Okay, it's standardized residual plot. So on save there is nothing much. In options no, and click on OK. So this is your residual plot and you can see that. So it's almost normal, so residuals are almost normal, so it follows linear regression well. So you'll have here, so in descriptives you have a simple descriptives correlation. Okay, so model summary is an important one. You have to click on adjusted r square. Now here we will click on r square only. Adjusted r square is means that when we have more than one independent variable, we will just look for adjusted r square if we are interested in what percentage of that independent variable contribute. So there is no confounding here, confounding factor. So we have another table, so it is statistically significant. You can have the coefficients here, so we will go for unstandardized coefficient. So x2 will be this one, this one. So you have like y is equal to x1 a plus b x2. So a will be this one, b will be this one, so a plus b x2. So that's about simple linear regression. Now just go for multiple linear regression. So in multiple linear regression also the same way we follows. So we will have analyze, we will have regression, we will have linear. So independent variable you can give on x3, balance are same, you can give on OK, and your multiple linear regression will be formed. Here you can just go for r square, adjusted r square, anything can be is okay. You go for adjusted r square is that whenever there is a confounding factor we will go for adjusted r square. So we will have a significant value here 0.05015, and in the coefficient you can have those a plus b x2. So here our regression equation is y is equal to a plus bx1 plus cx2. A will be this one, b will be this one, and c will be this one. So you can give like that. So what does this mean? It actually mean that for, let's say, like x2, let's take x2. So we will say that for a unit change in x2 there will be 1.345 mean increase in x1. Similarly in x3 also we will say for a unit change in x3 there will be 0.480 mean increase in x1. So that is what this coefficient means. So you have to make sure um, how to intercept this one. So next we will go for quadratic equation. So here q1 and q2, this follows quadratic only, it does not follow no linear. So you can just check it by scatter plot also. So sometimes our data don't follows linear, so you have to make sure that if does not follow linear, then your R square value will be very low, and hence what you find will be it will be not be adequate. So here you can see there is a tilt here, so it follows a quadratic. So quadratic equation will be a plus b x1 plus c x square. So we will go for quadratic. So in quadratic you can have analyze, and in the analyze you can go for here regression. There is curve estimation. In the curve estimation you will have quadratic models in the quadratic. So here dependent variable, let it be q1 and independent variable be q2, and then click on OK. If you need ANOVA table, you can click on the ANOVA table also. So here my quadratic equation, yeah, my quadratic curve has fitted clearly. So you can see that it has fitted clearly. So again you are unstandardized here, 2.266 for q2, and this is your next quadratic. As I said, y is equal to a plus b x1 plus c x square is your quadratic equation. So c will be this one, this is your constant, and you can check this significant values also. So as I said, you can check this R square. So if you put a linear curve, you won't get this R square. So here it is clearly indicated 0.923. It shows that 92% is can be told by this curve. So it's a great deal. So you have to know how to say about this, where we use the R square value. So always remember, you should use adjusted R square value only. Here also you can make a linear about scatter diagram, you can make a linear curve, and in making linear curve you can go for analyze and again regression curve estimation. Here you can give linear. So my dependent variable was x1, independent variable was x2, linear. You can have that curve. So here you can have that curve. So here your R square value is 0.60 percentage only, it can be explained here. So like this you can make your curve. Okay, so that's all for today video. So I hope that everyone liked this video. So if you didn't subscribe my channel, please subscribe it, so whatever videos I am putting in the future you will get a notification on that. And if there is any doubt, comment below, I will be gladly answering your questions. And thank you very much.